Okay, so we're going to do Unit 2, Lesson 1, Real Valued Functions. A function is a special type of relationship. We certainly talked about functions last year in Algebra 2. Calculus actually is the study of the 4 major operations on functions. We'll get more to that later on. Alrighty, so a relationship relates one set of items called the domain to another set of items called the range. And that's for relationships. And not all relationships are functions. A relationship may be represented by a graphical mapping. This is a mapping that I have here. This is an example of a mapping, this first thing here. A relationship may be represented as a mapping, a set of ordered pairs, or a graph. And lots of different ways you can represent a particular relationship. So this relationship is a mapping. I have the domain here. This is the domain. And the domain maps to the range. Let me get that in here, buddy. I have it written down here. It maps to the range, and notice it's very specific. This is a very deep, can be a very deep topic in upper level math classes, but if you notice this, the arrow goes to the right, goes from the domain to the range, from the domain to the range. The arrows are very specific. Another word that we can use for the domain is called the independent. The independent, you can also call the domain the independent, and the independents map to the dependent. So the dependent coordinates are dependent on the independent coordinates. And the other thing you can call the domain, you can call the domain the inputs. And the inputs map to the outputs. Another thing that I would like to add is you can also, if you're talking about a graphical relationship, you can talk about the preimage maps to the image. A little FYI there. As ordered pairs, relationships as ordered pairs, you can have the domain, the range, independent, dependent, input, output, doesn't matter. So example 1, we're going to look at the following relationship. Consider the following relationship given as a set of ordered pairs. We're going to name the domain, and we're going to name the range, and we're going to create a mapping for this particular relationship. So the domain is going to be the first coordinate of the ordered pair. So the domain here, we're going to try to do set braces. The domain is going to be 4, 2, 7, 9. So there's 4 elements in the domain, and in the range, looks like there's going to be an 8. I don't want to write the 8 twice because 8 is 8, a -2, and a 0. And those are the 3 values in the range. And if I want to create the mapping for that particular relationship, I'm going to list each member in the domain. Full domain red, I go 4, 2, 7, 9. And 4 we see maps to 8. Well, let's go ahead and write the range values down. 8, -2, and 0. I'm going to come up with my little red tool. 4 is going to map, look at that, that's cool, maps to 8. 2 also maps to 8. 7 maps to -2. And 9 maps to 0. And you are, sorry, you will be asked to do a mapping on the assignment. Mappings are very easy to do. You have one-way arrows that map from the domain if I can spell to the range. The domain always maps to the range. A function is a special relationship. Well, let's pause for a minute. A function is a special relationship. A relationship that maps each member of the domain to exactly one and only one member of the range. The relationship in example number 1 is not a function since 4 maps to 8 and 2 maps to 8. So this particular relationship is just a relationship. It is not a function. A function is a special relationship. One member of the domain to exactly one and only one member of the range. All right, so here we have an example number 2. Let's name the domain. We go braces for domain. Domain 1, a 2, a 3, and a 4. The range, I go green for range. The range 4, 5, 6, 7. And note here that each member of the domain only maps to, each member of the domain maps to a distinct Y. And we see here in this example, this particular relationship is yes, indeed a function. This is a function. Because map 1 only maps to one number, 2 only maps to one number, 3 only maps to one number, and 4 only maps to one number. So that is a function. And if you notice in this, yeah, I had 4 going to 8 and 2 going to 8, therefore that was not a function. Okay, so example number 2, use the mapping to determine if the following relationships are functions. And we will have an explanation, yes or no. So let's go ahead and create our, first of all, let's get this little guy out of here. I don't know why he's here. Uh-oh. Can I catch it? Yes, I can catch him. Let me erase him. Okay, so let's list our domains here. We're going to go 1, 2, 3, 4, and we're going to list our range values 4, 5, 6, 7, and we're going to do our mappings. And 1 is going to map to 4, 2 is going to map to 5, 3 is going to map to 6, and 4 is going to map to 7. So, yes, no function. This is a function. This particular guy is, yes, indeed a function. And our explanation, since each x Well, let's go domain value, since each domain maps to only one range value. And that's our reason. And if you have an assignment that asks, explain why this is a function, you need to use the definition of a function, and the definition of a function is right here. Where's that definition of a function? It's right here. I lost it. Each domain, each member of the domain to exactly one and only one member of the range. Okay, that's the definition that you're going to have to use to prove something is a function. Example number 3, let's use a mapping to determine if the following relationship is a function. So let's list the domain values, -3, -2, 1. And I don't want to repeat the -3. Because I'm only going to list it one time here. And my y values then are going to be 9, 4, 1, and 8. I'm going to use my mapping. 3 maps to 9, -2 maps to 4, 1 maps to 1, and if I notice here, 3 maps to 8 as well. So this guy is not a function. And our explanation here is since -3 maps to 8 and 9. And when we do a graphical representation on the XY coordinate axes, it's going to be much easier to see what a function is or is not. So moving right along. Functions in the Cartesian coordinate system, which is the XY land. Let's talk about functions in XY land. When discussing functions in the Cartesian coordinate system, it is most common for the domain to be a set of x values and the range to be a set of y values. Hence the notation y is equal to f of x. And it's amazing, we certainly use this notation f of x in algebra 1. We use this notation in algebra 2. Usually f of x is a rule that takes a certain x value, applies the rule, and outputs a specific y value. F of x is an expression in x. Y is equal to f of x is an equation in x and y, or in x and f of x. Consider the following right here. This usually you have y is equal to f 5x squared plus 7x minus 9. This is the same as this right here. They usually use this notation when talking about the graph of a function. You will see this notation when you're talking about the graph, this y equals notation when you're talking about the graph of a particular function. Both of these guys are functions here. So I think what we're going to do now, if I'm not mistaken, I think we're going to find some ordered pairs for some functions, and we are. Hey, let's do an example before I go on. Yes. Okay, so for this guy right here, let's do this example. Say I want to find f of -1 for this function. How do I find that? I simply put -1 in wherever I see x. Negative 1 squared is 1. That's going to be 5. 7 times negative 1 is negative 7 minus 9. This is going to be negative 16 plus 5. I believe that's going to be negative 11. So f of negative 1 is equal to negative 11. And this is the coordinate point that is associated with this guy right here. Negative 1, comma 11. That's a point. This x right here maps to this y. This x is going to map to this y. If you think about it as a mapping. Let's go to example 4 in our digital, in our interactive text. Example 4, consider the following function, evaluate the function, the specific value, state the corresponding order pair. Please simplify. So f of 3 is going to be easy. I just put 3 in wherever I see x. So it's going to be 3 squared minus 9 times 3 plus 2. Help me with the arithmetic. This is going to be 20. No, this 3 squared is 9. Duh. Minus 27 plus 2. And that is going to be, is that negative 16? True or false? True. So the point then, the corresponding point, let's put him out here, is going to be 3 comma negative 16. Let's find f of negative 1. F of negative 1 is going to be negative 1. We need to put him in parentheses for appropriate notation. Negative 1 squared minus 9 times negative 1 plus 2. This is going to be 1. Negative 9 times negative 1 is positive 9 plus 2. I believe that's going to be 12. And the corresponding point is going to be negative 1 comma 12. F. The next two examples are abstract. I think it's going to be hard for some people to wrap their head around this. It's going to be harder for you to wrap your head around this. This expression we're going to use a lot next year. I just went over this with my calc classes, this f of a plus h. F of a is going to be a bit simpler. All you do is put a in wherever you see x. So f of a is going to be a squared minus 9a plus 2. And you can't simplify that. What is the ordered pair? The ordered pair is simply a squared minus 9a plus 2. Bam. That's the ordered pair. This rascal is going to be a bit more complicated to figure out what the simplification of f of a plus h is. So wherever I see x, I'm going to put a plus h. I'm going to be very careful with my parentheses. I'm going to go a plus h squared minus 9 times a plus h plus 2. A plus h squared. This guy here is actually, this guy actually is going to be a plus h times a plus h. I'm going to distribute the 9, negative 9a, negative 9h plus 2. And now I have to multiply these two binomials together, which is going to be a squared. I'm using the FOIL method. AH plus AH is plus 2AH plus h squared minus 9a minus 9h plus 2. That thing does not simplify. We are only going to write the ordered pair this way. The ordered pair that is associated here is simply going to be a plus h, comma, f of a plus h. 2 parentheses. Well, let's keep on going. It is important to note that the function values are y values dependent on certain x values, and the order pairs are on the graph of the function. Okay. More about domain and range. The set of x values that outputs a real number. Here you go. This is important. The set of x values that output a real number is called the domain of the function. The set of y values created by the set of domain values is called the range. The reason why this is important, if I look at this particular function, because we're going to consider the following function, evaluate the function at specific x values, and state the corresponding order pairs, ... But we're going to state the domain here of the function in set builder notation. So this is a function right here. This is called a rational function, and we're going to spend a lot of time. We're going to have a whole unit. Chapter 4 is about, unit 4 is about rational functions. The domain of that function is the set of all x values that output a real number. If we jump ahead to this example and try to look at f of 6, f of 6 is going to be 6 minus 2 . And if we try to evaluate the function at 6, we get 6 minus 2 over 6 minus 6, and we get 4 over 0. And 4 over 0 is not a real number. So it is not a real number. Therefore, 6 is not in the domain, but anything else I put in would output a real number. So the domain of this function in set builder notation is all x such that x does not equal 6. And there you go. X can be anything but 6. That is the domain of that function. Oh, I should have put the domain down there where I asked for it, but I forget. So what's f of 1? F of 1 is going to be 1 minus 2 over 1 minus 6. 1 minus 2, I think, is negative 1 over negative 5. Check my arithmetic, which is 1/5. Please check my arithmetic. So the order pair is going to be 1 comma 1/5. It's going to be very important that I can handle these rational functions because I'm going to graph these rational functions. F of 2 is going to be 2 minus 2. That's interesting. Over 2 minus 6, which is 0 over negative 4. That's not a real number, is it? You have 0. So that's going to equal 0, and the order power then is 2 comma 0. And we know when the y coordinate is 0, this is going to be the x-intercept of that function. Here's a side note. Does that function have any other x-intercepts? Is there any other place that function will have an x-intercept? And f of a, we're going to go f of a, we're going to put a in, and it's going to be a minus 2 over a minus 6. And that's what the output is. So the point then is simply going to be a comma a minus 2 over a minus 6. And we can't simplify that. And we will postpone the discussion of the range of this function. So I think that's going to give us enough information to kind of get started.